Hey, hi everyone. Welcome to our channel, Tech J Infinity, and we are coming up with a series of understanding OpenRAN. So today we'll try to understand the basic of OpenRAN. That what does it, what does it mean, and how this technology has been formed. So let us go with the definition of OpenRAN. So when you ask anyone what does open RAN means, so basically open RAN is you can see that it is a new approach to build the mobile network that disaggregates the virtualized radio access network that includes the components of the RAN. So we'll come to that also. What are the components of the RAN? And it allows the interoperability between equipment from different vendor. Now when this definition comes into our mind, again we think of that what are the benefits we are getting out of open RAN. So if you can see sorry, if you can see my screen, you can see that we have vendor diversity, we have flexibility, and we have cost reduction. So, like say, we have told that it allows the interoperability between equipment of different vendors, which says vendor diversities. It allows operator to choose components from multi-vendors, potentially reducing the costs and increases the supply chain resilience. So what does that mean? So if you if you are aware of RAN network, as per 3GPP specification, it talks about that RAN has been disaggregated into CU and DU, that is centralized unit and distributed unit, and then it is connected to your radio unit, right? So this is what RAN consists of, and it comes from your 3GPP specifications. So when you say your CU and DU is from different vendor and RU is from different vendor, and you are connecting it, that make your network architecture as an open RAN architecture. And when you have different radio unit, you have the availability of different radio units from different OEMs. That gives you a vendor diversity, and which may gives reducing in the cost of the radio unit, availability of different features and different kind of radio units from different vendors. So this is what is the benefit we are getting out of open RAN. Then we have something called flexibility and scalability. So the disaggregated and virtual nature of open RAN makes it easier to adapt the changing network demands and scale up or scale down as needed. So we can have different DUs connected with several numbers of RUs, or that depends upon how many RUs a single DU can support. And then we can have different kind of flexibility and scalability. We can scale up or scale down depending upon the requirements what we are having. Then with this, we have something called cost reduction. By leveraging open source software and white box hardware kind of a stuff, OpenRAN can reduce the overall cost of the network deployment and operation. This is the major benefit coming out of when you have OpenRAN. And so this is what OpenRAN talks about. So the key features of, when I say what are the key features of OpenRAN, again, and in key features I can say that disaggregation is the first one. Okay, which talks about disaggregation of CU, DU, and CU, DU, and RU. Okay, so this is what OpenRAN talks about, and the basic information or basic understanding of OpenRAN. Now let's move towards the next slide, which talks about evolution to 5G OpenRAN. So the question comes in everyone's minds whether Open RAN itself is a technology or what. So Yes, we do agree that Open RAN is a technology, but the base technology has to be 5G, 4G, 3G, 2G, whatever you have to apply. So that depends upon how you are you know architecturing your Open RAN. So Open RAN is basically a technology which gives us a benefit of having uh, openness in your RAN. Now RAN can be based out of these technologies called 4G or 5G, or going forward it may be 6G also. So this is how evolution of 5G Open RAN comes. And as I have already told in last slide, that 3GPP introduced the DUCU concept as the evolution path towards VRAN, that is virtualized RAN. So if you see my this side of an architecture, you can see this approach comes from 38.801 specification, which talks about disaggregation of BBU, which we were having in legacy technology, which we called it as 4G technology. Now that BBU has been disaggregated into CU and DU, and then we have something called radio unit, right? So now you can see we have a comparison between uh, 4G and 5G technology, and how things have been changed as per 3GPP. You can see this is your core network. We call it as LTE EPC, and that has been move towards BBU. We call this guy as eNode B in legacy technology, and this has been connected with your radio unit using what? Using common public radio interface, right? So this connectivity we call it as front haul, and the protocol being used over here is common public radio interface. Now, when you talk about 5G technology as per 3GPP, we have the same 5G core network. New nodes have been introduced in 5G code, and that has been connected with your CU, which talks about the connectivity, which talks about the backhaul. Same goes in 4G also. And when you have CU and DU disaggregated as per BBU, so CU and DU makes your BBU, which was in 4G. So this we can say that BBU has been disaggregated into CU and DU, and in between we used to have a mid haul, and then from DU to RU again we have a front haul. Here we have used enhanced common public radio interface, which has its own benefits. So we can have a different session on that, with respect to what is the difference between common public radio interface and enhanced common public radio interface. The major difference is the transport protocol between CPRI and enhanced CPRI is differ. Here we were talking with respect to fiber communication or fiber protocols being used, and here the transport protocol being used is Ethernet packets or Ethernet transport protocol. So this is the major difference, and then we do have more differences. And this is a bottleneck. We cannot use it for larger distances. Now when we have enhanced CPRI, we can use it for larger distances also. So this is what is the major difference coming in picture from CPRI versus enhanced CPRI. But yeah, we can have another session on that. And this is what evolution of 5G Open RAN when we compare it with respect to the legacy technology. Now when I say that BBU, so if you see, this RU is going to connect with an RF antenna, and this is going to radiate, right? And this is your mobile, which is going to connect with this particular guy. And this interface, we call it as over the air or UU interface. This is where the packets has been spread over the air towards UE, and in downlink when sent from G node B or RAN towards mobile. UE is as in mobile, that is user equipment, or when UE is sending it out to G node B, it is in the uplink direction. So this is what how the connectivity is all about. But when you talk, we need to have the connectivity, and we have to send out the packets So we have to follow a protocol, a set of rules, so that we can send out the packets from eNode B or gNode B towards mobile or user equipment. And that set of rules is called as protocol stack. So that is protocol stack, and it is in the form of stack layers. So when you start from the upper layer, or you can say L3, that is called as RRC. Then we have something called PDCP. Then we have something called RLC, and after that we have MAC layer and physical layer. So these are all are the protocol stack layers we have defined from 3GPP specifications, and each stack layer is having its own uh, specification. Either it is from 4G point of view or 5G point of view. So when we talk from the 4G point of view, the specification numbers starts from 36 dot, and when we talk from the 5G point of view, it is 38 dot, whether it is from RRC, PDCP, RLC, MAC, or PHY. So this is the protocol stack we are following when we need to connect. This is your antenna. I'm again preparing this diagram, and this antenna is connected to your user equipment. So this is what the connectivity is all about, and we need to have connectivity between antenna and UE, and we need to have a connectivity between antenna and UE, and that connectivity has to be followed by a set of rules, and that set of rules is called as protocols, protocol stack, or you can say protocols. So that protocol stack is in the form of different layers starting from RRC, PDCP, RLC, MAC, and PHY. And when you talk from the 4G perspective, this all protocol stack is in the form of software, and it lies inside your BBU. But when you talk from the 5G point of view, this protocol stack again has to be disaggregated with CU and DU, and some part also in radio unit. So this is what we call it as the disaggregation of E node B or BBU towards CU and DU, and with that we have RRC and PDCP, coming inside your CU, and RLC and MAC coming it over here, and phi also has been disaggregated into two part. One is high phi and low phi. So high phi remains here and low phi remains here. So this is what the evolution of 5G Open RAN, or you can say 5G, has been introduced from the 3GPP specification point of view. And when you say CU, so some vendors come up with the disaggregation of CU into CU-CP, that is control plane, and CU-UP. So when you say CP, this is your RRC. It looks for the RRC protocol stack layer, and this looks for your PDCP. So because this is packet data convergence protocol, which has the functionality of looking into the packets, the IP packets which is coming from the external world, and RRC is the one who is looking into radio resource control, and it talks about control signaling. So we'll have this functionalities going forward. We'll try to understand that too. This is what evolution of 5G Open RAN. Now this is what we have this for this session, and I'll come up in the next session of this series. I'll be discussing about the functional splits. So what do we understand from functional splits, and we will try to understand from the 3GPP point of view, and the functional split meant for ORAN, that is 7.2x functional split. What does functional split means, and all of them. For more information, please do subscribe our channel. And we used to have sessions on the protocol level, on the ORAN level, the log analysis. So you can connect us with on these numbers, or you can mail to us. We provide sessions on that. And please do follow our YouTube channel. Thanks everyone. Stay tuned for next session on functional splits that is going to upload in a day or so. Thanks everyone.